Okay, today we're going to go over section 10.1, area of parallelograms and triangles. So here we go. Area of a rectangle is area is equal to base, area is equal to base times height. For the area of a parallelogram, it is also area is equal to base times height. And for area of a triangle, we've got area is equal to 1/2 base times height. Now, one important thing to remember for all three of these formulas, and this is something that I would write down, is that the base and height must be perpendicular. Draw a little perpendicular symbol there. So again, you can see in all of these cases that the height is forming a right angle with the base. In this case, here's the height forming a right angle with the base, and here's the height forming a right angle with the base. So you must have the base and height perpendicular, or the height forming a right angle with the base, when you're picking the numbers to plug into these formulas. So that's a key thing. All right, the next one on example 1, it says find the area of the non-shaded region. So we can see it looks like a big 9 here, and we want to find the area of all that stuff, but we don't want the area of this shaded region. So we've got to get rid of that part of it. So to do that, there's different ways you could do this problem. I think it's helpful to split up the problem into a few different sections and then deal with them separately. So if I divide there and there, then basically I have this rectangle, I have this rectangle, and I have this rectangle, and then I want to get rid of this rectangle. Okay? So if I just take each section separately, if I first start off with say this section right here, okay? If I want to find the area of this section, it's a rectangle. Here's my formula, base times height. My base and height form a right angle with each other, so I can go 10 times 20, 30, okay? Then I also can find the area of this section right here, but to do that, I got to pay attention to the different dimensions that I have going on here. If I look to see how long it is from here to here, then I can carefully look at that. I can see this is 10, I can see this is 6, and I can see this is 2. So if I add all those up, then I get 18 for that dimension. And then I have to carefully pay attention to what this length is, okay? If I know this whole thing is 22, then I know that if this is 22 and this is 8, if I do 22 minus 8, then that will give me this section right here, which gives me the 14. Okay, so to find the area of this section, then I'm accounting for 18 times 14. Okay, next one, if I want to find the area of this little rectangle, I can just go 8 times 2. And lastly, I want to make sure I get rid of this rectangle. And the area of this rectangle is 6 times 4. If I want to get rid of it, then I'm subtracting it away. Okay? And so now I can go ahead and take care of each of these separately, and then get that final answer combined together. So I get 10 times 23 is 230. 18 times 14 is 252. 8 times 2 is 16, and 6 times 4 is 24. You get that all plugged into your calculator, then you end up with 474. And don't forget your units. In this case, we're dealing with centimeters. The area is always squared, so I've got centimeters squared for my answer. Okay? All right, moving on to example 2. And again, if you don't get some of this, feel free to pause it on your video, and that can help you have some more time with it before moving on to the next thing. All right, on the next part, I'm gonna make that go away here. Sorry about that, let me get that moved. There we go. Okay, so next one is asking us to draw the altitude of the parallelogram or triangle in 2 different ways. So again, an altitude is a height, and a height is going to form a right angle with the base. So we talked about this in chapter 5. Drawing an altitude goes from a vertex and forms a right angle with another side. So one altitude that I could draw here would be that one. It goes from the vertex, forms a right angle with the opposite side. But I could also extend out this side and drop from this vertex down. And that also represents the altitude or the height. You can see that length is going to be the same as that length. Again, it just kind of depends on what kind of angle you're dealing with, if it ends up being outside the figure or inside the figure. But both of those represent the height or the altitude of that parallelogram. Okay, same type thing over here for 3. If I try and draw the altitude from this vertex to this side, I can drop that altitude or height down, and it's going to form a right angle with the base there. If I want to go from this vertex over to this side, then I can do that as well to where it forms a right angle. Okay, so again, it just depends on which vertex to which side you're going to. All right. Now if we go and look at examples 4 and example 5, it says find the area of each parallelogram. So again, it's telling me it's a parallelogram, so if I look at my formulas at the top, I see that area of a parallelogram is base times height. And you just want to make sure, sometimes they give you more information than you need, and you want to make sure you pick the right numbers to plug into the formula. So again, base and height have to form a right angle with each other. In this case, this is the height. And I can see it's the height or the altitude forming a right angle with the base, which is 5. And that means I'm not going to use this 4.5 at all. Sometimes they give you some extra numbers that are kind of distractors. So my base is 5, my height is 4, and if I multiply those I get 20, and then I want to pay attention to my units. In this case it's going to be inches squared. So that's number 4. And then over here for number 5, I'll do it right above right here. So again, it tells me it's a parallelogram, so I can use my formula, area is equal to base times height. In this case, my base that they're showing me is just going from here to here, which is 2. Yes, they did extend out that side, so they could drop down and do this height or altitude here, show that height or altitude, which is 3.5, but I'm just dealing with this actual length here as the base. So I've got 2 times 3.5. They didn't give me any extra numbers this time, so I didn't have to deal with that. And 2 times 3.5 gives me 7. It again includes your units. Oh, they did give me an extra number over here. But again, I'm looking for the base and the height that actually form a right angle with each other, so that's why I didn't need this number. And so in this case, I get 7 centimeters squared for the area of that parallelogram. All right, so let's go ahead and keep moving to example 6. Okay, so on this one, it is asking me to find the height of the parallelogram. So again, I'm using my same formula, area is equal to base times height that we were using. In this case, I can see that they changed the question on me here. They're asking me to find the height, and they gave me the area, and they gave me some extra dimensions on here. So plug in what you know, solve for the thing that you don't know. Okay, in this case, they gave me the area is 24. Okay, make sure you're looking for the base and the height that form a right angle with each other. If this is the height I'm looking for, then I know this is the base, and I know that this has to be congruent to this. You learned in chapter 6 that opposite sides of a parallelogram are congruent. So if that's 6, that's 6. And now my base and height are forming a right angle with each other. So my base is 6, and my height here is what I'm looking for. All right, so if I want to solve that, if I want to get h by itself, I can just divide by 6 on both sides, and that gives me 4. And again, there's no units to include this time because they didn't give me any units in the problem, so I can just leave it as h is equal to 4. Okay, all right, so moving on here. If we look at number 7, get that switched. Okay, so these can be a little trickier for people just because there's multiple steps to it. But again, plug in what you know, solve for what you don't know. So number 7, it says find the area of ABCD and then find the measure of DE to the nearest tenth for ABCD. And it says that segment FC is one of the heights of the parallelogram. And they're showing me here that the area is equal to 9 times 13. So they kind of helped give me a start here. We're seeing here is the 9, which is the height, and the base that we're dealing with here is this DA, which is 13. And 9 times 13 is 117. Okay, so that is the area of that parallelogram. That wasn't hard to find, but that's not the question it's asking for. It did want us to find the area. We did that, and now they want us to do more. They want us to find the measure of DE. Okay, if I look here, DE is also a height or an altitude. It's just dealing with a different base. They're kind of saying this is the base, and they want us to find out what this height is. Okay, so it's almost like this is the first height that we dealt with. We'll call that height 1, and this is the first base we dealt with. We'll call that base 1. Okay, but now we're dealing with another height because they're just going from, you know, a different vertex to a different side, and so now we have a different base that we're dealing with. So we'll call that one base 2. All right, so if I use my formula again, area is equal to base times height, the area is not going to change. Okay, the area is still 117 for that particular figure, so I'm going to plug that in. Okay, but I'm going to deal with base 2 and height 2 this time. Okay, so base 2 is now 9.4, and height 2 is what I'm looking for, this DE. Okay, so to get h by itself, like we did on the last one, I just need to divide by 9.4 on both sides. And when I do that, 117 divided by 9.4 is 12.4 inches. And that is height 2, which we just said is DE, which is what they specifically asked for us. So I'm going to change it to that. Okay. Number 8 is very similar. They just didn't give us a kind of head start here. So if we go ahead and look at this one, we can see that in this particular case, we can see that, you know, here's a height and here's a base. And we can see that here's a base and here's a height. You know, if that's 3.8, then that's 3.8 if it helps you to look at it that way. Okay? And I can see that, you know, this is a base. I'll call that base 1. And this is the height that forms a right angle with that base. So I'll call that H1. Okay? And if I use those two, I can find out what the area is of that parallelogram. So area is equal to base times height. And I'm going to use base 1 and height 1. So if I plug that in, I've got 3.8 times 4. And so the area of this figure then is 15.2. Okay? But now I need to do a little more work. And so in this case, again, here is my base 2, and here is my height 2 that I'm looking for. Okay, so again, if I use my parallelogram formula again, it's just this time I still know the area is 15.2, but in this case I'm going to use base 2 and height 2. So base 2 is 9.5, and height 2 is what I'm looking for. And if I want to go ahead and solve for the height, the new height, I can go and divide on both sides again by 9.5. And so that new height that we are looking for is 1.6. All right, you get to hear a bell. You haven't heard a bell in a while. All right, so almost done. So next is number 9, 10, and 11. So in this case, it says find the area of the triangle. So we already talked about the formula for the area of a triangle. And in this case, it is 1/2 base times height. Again, for a triangle, we remember the base and height form a right angle with each other. So in this case, I know that this is my height. And I know that this whole thing is the base, but I don't know what this whole thing is yet. I have to figure out what that piece is. Okay, to do that, they didn't give it to me, so I have to find it. If that's a right angle, I know that's a right angle. And so be thinking of what formula can I use. If it's a right triangle, I know two sides, and I want to find the third side. Okay, and hopefully you're thinking of Pythagorean theorem. That one doesn't go away, that one gets used a ton. So if I go and just call this length x, okay, then I know that 25 is my hypotenuse because it's across the right angle, so I know it goes in for C. And I know my A and B then are my x and my 7. Okay, if I go and solve for that, I've got 49 plus x squared is equal to, is that 625? If I go and subtract 49 from both sides, then I end up with 576. And if I go ahead and take the square root of each side, I end up with x is equal to 24. All right, so that gives me this length right here. Squeeze that in. So from there, I can figure out what this whole thing is. 30 plus 24 is 54. And now I can use the information to figure out what the actual area is of the triangle. So in that case, I've got my whole base is 54, and I know my height is 7, they gave me that. And when I plug that in the calculator, you can either plug it in as 0.5 times 54 times 7 equals, or you could do 54 times 7 equals and then divide by 2, whatever you prefer, and you should get 189 inches square. Practice putting that in your calculator to make sure you're getting what I'm getting here. And that is the area. All right, if we look at the next one on number 10, we know that again it's a triangle. So I'm using my triangle formula for area, 1/2 base times height. Base and height have to form a right angle with each other. So in this case, I can consider this to be my base and this to be my height. Okay, because since it's a right triangle, those two sides are the base and the height. They are the ones forming a right angle with each other. So I got 1/2 times 3 times 4. And once I get that plugged in, then I end up with 6. And they didn't give us units on that one. All right, again, triangle, so area equals 1/2 base times height. And then again, just make sure you're careful picking the base and the height. In this case, here's my base, which is 11, and here's my height, which is 2.5, that's forming a right angle at the base. So I get area equals 1/2 times 11 times 2.5, and once I get that plugged in, I get 13.75 feet squared. Make sure you remember your units are going to be squared for area. All right, and then last one, I'm going to move it up so you can see that a little more, or so we have a little more room to write, but that will be the last one here. Okay, so in this case it says the area of a triangle is 100 inches squared. The ratio of the base to the height is 2 to 4, and find the length of the base and the height. So in this particular case, if I think about what's going on here, they're telling me the area is 100 inches squared. They're kind of telling me some information about the base and height. They're not telling me exactly what they are, but they're telling me some information. They're telling me the ratio is 2 to 4. So I do not know what the base and height are, but I know that since they talked about the base first, that's related to the 2, and because they talked about the height next, that's related to the 4. Okay, so I'm going to give an expression for the base and the height. I'm going to say the base is 2x and the height is 4x. Okay, so that's at least a relationship that relates those. And if I go and use my formula for area of a triangle, I can plug in what I know and solve for what I don't know. So my area is 100, they gave me that. My base, I'm going to plug in 2x, and my height, I'm going to plug in 4x. So in this case, if I go ahead and get that kind of simplified down a little better, I've got 100 is equal to, if I do 1/2 times 2 times 4, I'm left with 4. X times x, don't forget, gives you x squared. And from there, you can go ahead and divide by 4 on each side. You want to make sure the x squared is by itself before you do anything else with that. So I get 25 is equal to x squared. And then I can go ahead and take the square root of both sides. And again, technically I get positive and negative 5, but in this case, since we're dealing with the length of a side of a triangle, the positive 5 is the only thing that makes sense here. So our x is equal to 5, and then always pay attention to what the question's actually asking for. In this case, it wants us to find the base and the height, so we can go and plug back in for what we had to begin with. We know the base is 2x. We now know that x is 5. So we know the base is 10, and in this case, it's going to be inches. And same type of thing for the height. We said was 4x. We can plug 5 in for x, so we get 20 inches for the height. All right, and that is all for section 10.1. Again, if you have any questions, feel free to message me on Canvas, and I'd be glad to help you out.